Now, the next questions, page 238, question 9, and then question 10. So, a class of 25 students were surveyed to find out how many WhatsApp messages they each sent in a particular week. The results are shown in the table below. So, just to read this, one student sent between 0 and 30 messages, 2 between 30 and 50, 10 between 50 and 70, etc. Note that 30 to 50 means at least 30 but less than 50. A student is picked at random from the class. Find the probability that this student sent 50 or more messages. Okay, so in this group here, they sent 50 or more, so that's 10 people. This group here sent 50 or more, and this group here, so that's 5 people. Okay, so that's 10 and 7 and 5 out of a total of 25 students. So that gives me 22 out of 25. So that's the probability that someone sent 50 or more messages. A student is picked at random from those who sent 50 or more messages. Find the probability that the student sent 50 to 70 messages. So 50 to 70 messages is this part here. So that's 10 out of 22, isn't it? Because out of those who sent 50, which we already said was 22, find the probability that they sent 50 to 70. So that's 10 out of the 22, which can be simplified as 5/11 over 11. Now, using the mid-interval values, I cannot stress this enough. This comes up all the time. So you need to know how to find the mean using mid-interval. So using mid-interval values, estimate the mean number of messages sent per student. So these are our intervals. So the middle of each interval is 15, 40, 60, 85, and 130. So I'm going to multiply each interval by how often they occur. 15 occurs once. 40 occurs twice. These values are coming from here. 60 occurs 10 times. So 85 occurs 7 times, and 130 occurs 5 times. Out of the total number of students, which is 25. Now 15 by 1 is 15, 40 by 2 is 80, 600, 595, and 650, all over 25. To add that, it gives me 1,940 over 25, which is 77.6 messages per student. So it says estimate the number of messages sent per student, and on average is 77.6. Now you can't really send 0.6 of a message. So I would be inclined to then just write 78. Now, the next part says the students also found the total number of WhatsApp messages they sent in this particular week. Use the data in the table to find the smallest value that this could be. Okay. So again, in this group here, if we go get rid of our mid-intervals, this one person may have sent no message. So that would be 0 by 1. These two people here could have sent 30. So we're looking for the lowest. It says here's the smallest value that the total number of messages. So that will be 2 by 30. 10 people could have sent 50. So that's 10 by 50. 7 people could have sent 70. So 7 by 70. And these 5 people could have sent 100. So we're looking at the lowest value. So that's 0, 60, and 500, and 490, and 500. So the lowest number of messages in total that could have been sent is 1,550 by all of the students in total. Question 10. There are 10 students in a class. All 10 of them sat a test. The table below shows the mean mark, the median mark, and the range of the marks. 32 was the highest mark got by a student on the test. use the range to find the lowest mark got by a student. Okay, so we know the range is 14. We know the highest mark is 32. So the range is found by the highest minus the lowest. So 32 is the highest mark. We want to find the lowest mark, so I'll call that x. So I'll take it away, and the range is 14. So that's minus x is equal to 14 minus 32. Minus x is equal to minus 18. X is 18. So the lowest minus the highest minus the lowest gives me the range. An external examiner suggested that 2 be added onto each student's mark. Find what the median, the mean, and the range would be. So I'm adding 2 to each mark, so that will just increase the mean by 2, because everything is just going up in 2. It'll increase the median by 2, but the range will still stay the same, because the highest minus the highest value will be increased by 2, the lowest value will be increased by 2, so there won't be any difference. It'll still be 14. Bob says whenever the median of a list of numbers is 24, then at least one of the numbers in the list must be 24. Give an example to show that Bob is not correct. Well, okay, I'm just going to use 4 numbers. I'm going to say the first one is 1, 23, 25, and 13. Now, the reason why I'm using, first of all, there's an even amount of numbers. There's 4 numbers. So when it's an even number of numbers, you know that you're going to have to add 2 numbers together to get the median. Now, 23 and 25 are either side of 24. So if I add the 2 of them together and divide by 2, I will get 24. 24 is not on the list. So it's not in that list of numbers. However, it's still the median. Okay, so Bob is not correct in what he said.